Good evening, everyone. I'm Saranya. Our topic is implication of 5G technology on big data. Let's see what is 5G and big data. Big data, as the name suggests, is a term that describes large set of data. It can be structured and unstructured. It's not the amount of data we are concerned of, but what we do with the data is what matters. That is, applying data science principles to it and drawing some useful insights. Now, let's try to understand the concept of 5G and how it is interconnected with big data. 5G is a wireless network that is offering an increase in transmission bandwidth. The main advantage of the new network is that they will have greater bandwidth, giving higher download speeds, eventually up to 10 gigabytes per second. Due to the increased bandwidth, it is expected that the new network will not just serve cell phones like existing cellular networks, but also be used as general internet service providers for laptops and desktop computers. And also will make possible new applications in IoT and machine to machine areas. Let's see how is 5G and big data related. Imagine downloading an entire 1.25 GB movie in 1 second. That's amazing, isn't it? Downloading huge data in just as a shorter span of time is directly pointing to big data. It means tremendous mobile traffic will be there, and to handle all of this traffic, companies are incorporating massive communication, caching, and computing resources. In short, 5G will revolutionize the handling of big data and will significantly improve communication, caching, and computing capabilities. 5G wireless network will also play a crucial role in big data pre-processing due to its 24/7 availability and the impact it can have on network storage capacities and computing capabilities.
Hi guys, this is Ganesh Cole. We'll talk about parallel processing in this section of our presentation. Parallel processing is a computing technique where tasks or processes are split into parts that are executed in simultaneously by different processors. Uh, Given the expected explosion in data and the requirement for near instantaneous processing, parallel processing system will be invaluable in the 5G world. Considering the prediction that the number of connected devices will increase 10 to 100 times, it can be concluded that big data techniques will play an important role, uh, as all the considered usage scenarios are based on extracting knowledge from the enormous amount of heterogeneous data. Over the years, many abstract models of parallel processing have been introduced in an effort to accurately represent processing, storage, and communication resources, allowing developers of parallel applications to visualize and take advantage of the available trade-off. Google's MapReduce is the most prominent cloud-based system for parallel processing. In the map stage, data is distributed within independent tasks on different processing nodes. Uh, each map stage task produces a set of key value pairs as its output. These outputs are then fed to reduce stage tasks where they are aggregated into smaller set of key value pairs that constitute the final output.
After having a good introduction about what is a big data and a 5G network, let us try understanding the architecture of the big data platform. As we know that the digital universe can comprise of all kinds of data in various formats such as text, images, audio files, etc., all of these can be considered as prominent data sources, and these are to be analyzed in a big data solution. These enormous amounts of data is passed through the ingestion layer, wherein the noise is separated from the relevant information. The ingestion layer must be able to handle the huge volume, the high speed data, and must be able to clean, transform, and reduce the data to be further used by Hadoop. The visualization layer, on the other hand, helps the data analyst to examine the different aspects of data in different visual modes. The Hadoop platform management layer is used to process the MapReduce and handle the other query languages like the NoSQL database by using the various HDFSs such as the Pig, the Hive, the Zookeeper, Scoop, etc. The Hadoop storage layer is a layer dedicated to store the data using massively distributed storage and also in processing that data. The security layer is basically designed for data protection. For example, we have sensitive information about a user. We need to protect this from the beginning of any big data system. Finally, having so many storage clusters and ingestion points, the monitoring layer is used to give a complete picture and thus increase the performance of Hadoop.
So with what we've talked about with the fifth generation of wireless communication technologies, we wanted to touch a little bit on the architecture and some of the infrastructure that is needed to implement these globally. When we're talking about it, the good thing about the 5G architecture is that it's going to be implemented in stages and it can be layered on top of the existing 3G and 4G network infrastructure and architecture. One of the ways that that is happening is through what's called 5G New Radio or NR and radio access networks. So what's happening is there are underutilized frequencies, the UHF or ultra high frequency ranges that are just not getting a lot of usage right now. So those can be repurposed. Those are between 300 megahertz and 3 gigahertz. And then the millimeter wave frequencies, the frequencies between about 1 gigahertz and 100 gigahertz. That allows us to utilize and specifically designate those frequencies to be used specifically for 5G. So since they already exist, there's not a lot of new technology that needs to be and new infrastructure that needs to be built to utilize this technology with the 5G. But there are new pieces of technology that have been created that have allowed for this, like multi-access edge computing, MEC. What it does is it decentralizes applications and moves them to the edge of the network, which allows those applications to actually be closer physically to the end user and allows for reduction in latency. It increases access, more real-time like access to RAN networks, and actually can support higher bandwidths, within that technology. Outside of that, there is one new technology that I thought was worth mentioning. It's called network slicing. What it allows us to do is utilize multiple networks simultaneously within the same physical infrastructure. So what that does is it creates the capability that we'll talk about a little bit later on for flexible network deployment, which is one of the big things that solves some of the challenges for 5G.
Now, let's talk about some of the challenges faced by the 5G networks and how they were solved using the big data platform. We all can understand that each platform doesn't come without its set of challenges which are to be handled. In the same way, 5G technologies has some significant challenges as well. Some of them are they would require a high frequency spectrum, they would need higher data rates, and also they would require a large bandwidth allocation. Now, let us discuss some of the challenges and how they would be handled using the big data platform. First, let's talk about proactive caching in 5G networks. Massive deployment of small cell base stations is going to be a key role for capacity and coverage enhancements in the 5G networks. However, the backhaul for these networks remains an important issue. Ideally, the capacity of backhaul has to be of the same order as the wireless links in order to avoid the bottlenecks in the delivery and sustain the huge traffic generated by the mobile users, especially due to the video streaming, the content shared on social networks, etc. In reality, deployment of such a high-speed backhauls is very costly. Thus, one way of tackling the backhaul bottleneck and satisfying the user's demands is to cache the strategic content at the edge of the network. This is known as proactive caching. This is possible by making use of both the big data analytics and machine learning to develop a proactive caching mechanism by predicting the popularity distribution of content in the 5G networks. After collecting the raw data of the user, Hadoop predicts the user's demands by extracting valuable information like the location area code, the HTTP request, etc., and uses this information to compare it with the previously connected raw data. This approach could achieve efficient utilization of backhaul offloading and enhance the user's experience. Experimenting the same procedure on 16 base stations has resulted in 100% request satisfaction and 98% of backhaul offloading.
In this section of challenges and solutions, we'll talk about network optimization. Big data analytics can be involved in several topics, including predictive wireless allocation, interference avoidance, optimizing the network, considering quality of experience, flexible network planning in light of consumption prediction. Uh, uh, One of the solution provided is like deployment of cache server in mobile content delivery network. Popular content such as movies can be delivered through a content delivery network, which is a method that is considered efficient by many mobile network operators. Uh, Distributed cache servers should be located near the users to achieve a fast response as well as to reduce the delivery cost. In hierarchical content delivery network, it is vital to place cache servers in an optimal location. Optimal cache server placement depends on several factors such as features and load of traffic in each areas, as well as the cost of storage and streaming equipment. To help the mobile network operators decide where to deploy their cache servers, data analytics methods can be regarded as a feasible solution.
So, as we've mentioned, 5G network technology does come with its challenges. Where I'll focus with this slide is on some of the more user-centric challenges. So some of those include latency, being able to bring out this 5G network technology at scale to really fully utilize its capabilities and powers, and the fact that there's just an infinite number of use cases. So there are some things out there that have been designed from big data techniques that can help solve these problems. Some of those are behavioral-based optimization, flexible network deployment, and flexible functionality deployment. Very similar in nature, but focus on a few different ideas. So from the behavioral-based optimization, one of the big use cases here is actually being able to predict which access point is needed next for the user. So really helps with prediction among where that person will connect based on their motion. The flexible network deployment, like we talked about with network slicing, allows for flexibility within delivering network access to different items, different machines, different users at any given different time. And then flexible functionality deployment looks at users across the board and really helps prioritize what users, those could be devices or people, need the most functionality and the lowest latency and the most computing power at any given time. So those are some of the challenges and some solutions to the challenges brought on by big data to the 5G network.
We are now familiar with the basic concept of what big data is, how it is processed, and what benefits we can get from it. We also learned about 5G and its role in big data processing. There are many areas in which big data analytics can be utilized in the network design process. The concept of gathering network data and correlating them with user trends and service requirements can indeed create an adaptive and user-centric network design. The use of 5G technology application in big data centered network architecture, as discussed, gives better efficiency and optimum performance to the devices. Here are a few predictions. Gartner predicts that by 2021, 4% of network based mobile communication service providers will launch 5G networks commercially. The Hype Cycle report mentions that from 2018 through 2022, organizations will most often utilize 5G to support IoT communications. We predict that the field of network design based on big data analytics will continue to flourish as more data are collected from the networks and processed to extract useful information regarding network behavior. Thank you.